Sum up with the advantages and disadvantages of raster data. The advantages of raster data, firstly, is it's very easy to understand. It's made of rows, columns, and values. Those values may or may not have numeric meaning, depending on the kind of raster that we're looking at, either categorical or numeric, continuous. The simple data structure of rasters is in a format that's required for easy manipulation of rasters by computers. And also the same format required for remotely sensed imagery, rows, columns, and values. Very straightforward. And we can represent variables in raster that have a high spatial variability. That means things that change constantly throughout space. This is something you can't do with vector data very easily. In vector data, the equivalent would be a tin, a triangular irregular network, to try and represent a continuous variable in vector, and those are unwieldy to work with. In raster, we can undertake surface analyses, neighborhood functions, zonal functions, etc., and they're easily implemented in rasters because of the simple data structure of that regular square tessellation. Rasters are fast in processing on computers. For example, overlay operations, working with more than one raster at the same time, are very efficient for large data sets because of the idea that rasters have that simple data structure that is a numeric array. And as such, unlike vector data, when you overlay it, there's no geometric algorithms or equations are required to overlay raster data because things are compared on a cell-by-cell basis very easily within computers. Can you think of more advantages of raster data? The disadvantages of the raster model. The first one is memory requirements. As we decrease the resolution of a raster layer, the memory requirements increase as a power function. And a power function looks something like this. I'll just draw it here. It's a curve that looks like that. For example, x squared. This would be a curve of x squared. And if we have the resolution on the x-axis and memory on the y-axis, well, if we take any given resolution, let's say this one, and we double the resolution to make it a smaller cell size, we would more than double the memory requirements necessary to store and therefore manipulate that particular raster within the computer or the GIS system. And so that's one disadvantage of rasters, is that the memory requirements grow as a power function of the linear resolution that we're using. So a cell that's 1 square meter in size would require more than half or more than double the memory of a cell which is 2 meters in size. That means 2 by 2 when I'm talking about the linear resolution again. And this is why mini raster data have to be compressed. So compression techniques are used for storage purposes. For example, the common ones like a JPEG or a GIF or a PNG that are used in the web are all compressed raster layers or raster images. And that's so that they can be transmitted with minimal bandwidth. Another disadvantage of raster is that discrete features have a look that's quite blocky depending on resolution. So you don't get that crisp edges or transitions between entities that you're representing, let's say on a categorical raster, you would on a vector version of categorical data. Another thing is resampling is required, and you'll see what that is later on in one of the other modules. but it's required for coordinate system transformation. And this leads to value location inaccuracies or changes. Unlike with vector data, which is very precise when changing boundaries, with raster data, we have to create a new raster in the new spatial coordinate system, and then assign that new raster cells from the old spatial coordinate systems and their values. And that leads to often changing of values somewhat, slightly between different coordinate systems for raster. And so with raster, coordinate system control is fundamental and very, very important when analyzing. Because rasters all use cells, which are two-dimensional, they are not good for location-accurate purposes. Anything that requires location accuracy should be done using vector points, vector lines, or vector polygons. Because whatever you represent in a raster becomes two-dimensional. So even a zero-dimensional point, 0D point, or a one-dimensional line, these become two-dimensional things in a raster when they're represented as a discrete set of cells. And so we don't know where within the cell, it could be here, it could be over here, it could be over here, that the original point was, or object was, that is being represented by that cell when we look at discrete object representation, like let's say a fire hydrant. The whole cell would become fire hydrant, and we don't know where the fire hydrant was within that cell. So we're limited in the amount of accuracy that we can assign to a cell reference for a discrete object in space. Also, rasters are non-topological, and that means that there are no spatial logic or relationships that can be used based on spatial logic to trace things through raster space, for example. The best example of this would be driving directions on a road network. Road networks are vector for the purpose that they are created with or represent lines and nodes. Where nodes are, you can change direction, like a crossroads, for example. And so through a road network, that connectivity can be represented in what are called topological tables. And those tables can then be used for doing things like least cost path analysis through, or network analysis through geographic space on that network. Networks aren't representable as networks within a raster because all we have is cells. And everything is recorded in a cell, and there are cells everywhere. So rasters aren't good for representing linear things. It's best done in a vector, depending, of course, on the purpose of your analysis. So there are many disadvantages to the raster model and many advantages. And whether you use raster depends a lot on what your goals are, what you have to analyze, and what you expect as the outcomes of your analysis. And hopefully you'll see how these things play out as we go through these different learning modules for the course.